Hi, in this lesson we're going to look at new sets of angles called linear pairs and vertical angles. Okay, so the first one we're going to look at is the linear pair, and it's two adjacent supplementary angles. And when you see them, they will form a line, right? Because if they're supplementary, that means they have to add up to 180 degrees. And if they're adjacent, that means they're going to be next to each other, sharing a ray and a vertex. Okay, so adjacent means they have to share that vertex, and then they're also going to add up to 180 degrees. So if I take this angle here, the one next to it, when it adds up to 180 degrees, together they're going to make what looks like a line along one side, one edge. Okay? So for my examples, it says find the value of x in each figure below. So I can tell I have a linear pair of angles. Oh, let me not skip this. This is important. Linear pair postulate just tells us that the sum of two angles in a linear pair is 180 degrees, which makes sense because we know that supplementary means 180. So if I add them together, I get 180. And so this is what we use if we're ever have to use that concept in a proof. So in a proof, we could use the linear pair postulate to say that two angles that are a linear pair add to equal 180. Okay? All right, so now let's look at this example. If I have two angles and they're adjacent, so when I look at the angle that I have on the left and the angle that I have on the right, so I've got this angle on the left, that's x, and I have this other angle on the right that I'm marking in pink. I can tell that they do make a line along the bottom. So they are a linear pair. So I can use my linear pair postulate to say that x plus the pink angle 100 should equal 180 degrees using my linear pair postulate. So then that's pretty simple to solve because I just need to subtract 100 on both sides. And I get that x equals 180 minus 100 is 80. And I know you probably could have just looked at that and done that in your head. 100, how many more degrees do I need to finish going all the way around the protractor, right? If I had a protractor sitting on here, well, I'd need to still go 80 more degrees. Okay? But as much as it's simple to do that on a picture like this, that would be much more difficult to do in a picture like this. So we did have pictures that looked similar to this when we did adjacent angles, and when we did bisected angles, kind of the same. And we looked at, do I add them together or do I say they're equal to each other? So when I look at my two angles, if I look at this one on top, that's 3x plus 5. And when I look at the one underneath, that's x plus 15. My linear pair postulate says the sum of those two angles in the linear pair, and I know they're a linear pair because they make up one side of that line. Okay, so they are a linear pair. The sum, so that means I add them together, of these two angles that means equals 180. Okay, so unlike this one where I could have just looked at it to see it was 80, this one it's really nice that I can set it up in this equation because now I just have to do the algebra part, right? I'm going to combine my like terms, so I'm going to put together my 3x and my x and get 4x. Then I'm going to combine my constants, my 5 and my 5, or that's not 5, that's 15. Look in there, 15. So my 5 and my 15 is plus 20 equals 180 degrees. Okay, so the next thing I need to do is I need to subtract 20 on both sides. And I'll end up with 4x equals 180 minus 20 is 160. Divide both sides by 4. and 1x equals 40. Now before I put my box around there, I'm just going to check that. I'm going to make sure that if I do 3 times 40 plus 5, and then if I do 40 plus 15, I'm going to make sure these two angles really do make half of that one side of that line, really do make 180 degrees. So 3 times 40 is 120, plus 5 is 125, and then 40 plus 15 is 55, and if I add those two together, 5 and 5 is 10, carry the 1, 5, 6, 7, 8, and then 1, 180. So it does work. So I am going to put a box around that. X does equal 40. Okay, so that's your linear pair. Two adjacent supplementary angles, and the postulate says I can add the two angles together to equal 180. Okay, the second type of angle we're going to look at today is called vertical angles. And vertical angles are across from each other when two lines intersect. So if I look at this figure that I have here, when I look at angle A, and I look at angle B, those two angles are considered to be across from each other when I have two lines intersecting each other. Okay, so angle A and angle B are vertical angles. Angle A and angle B are vertical angles. Okay, so then we have this next sentence that says vertical angle postulate. Vertical angles are always congruent. Angle A is congruent to angle B because we said A and B are vertical angles. Okay, the reason that is because if you think we just talked about linear pair, right? So if I look here, I would have a linear pair if I looked at the two angles A and this one over here that's not marked for me, right? If I look at this one that I'm going to color in this kind of teal color, okay? Those two angles are a linear pair. Whatever this is plus angle A makes 180. But look, if I rotate this way, whatever this is plus B makes 180. So that means A and B have to be the same thing because they both add together with this teal angle to make 180 degrees. Okay, I could have also used this side and said angle A plus this teal angle make 180, and so do angle B and that teal angle. So angle A and angle B have to be the same thing. But look at what I just drew. There are actually two sets of vertical angles at every single intersection of lines. So let's say I called this one C and I called this one D. I could also say angle C and angle D are vertical angles. Okay, and my vertical angle postulate says vertical angles are always congruent. So angle A is congruent to angle B, and also in this picture, angle C is congruent to angle D, meaning they have equal measures. Okay, they have equal measures. All right, so now that we've looked at that, let's look down here and it says example, find each missing angle in the figures below. So I'm probably going to have to use both types of relationships. First thing, I'm going to look and see what information do I already have. I know that the measure of angle 2 is 45 degrees. So if angle 2 is 45 degrees, the first thing I'm going to do is I'm going to see, well, what is the vertical angle to that angle 2? Because it's also 45 degrees. So that's going to be the angle 4 is also going to be 45 degrees. Okay? Then the next thing I'm going to do is I'm going to look at a linear pair. So I can just look at angle 2 and angle 1 at that linear pair. I know that if I take 180 and I take away the 45 because I have a full line there, right? I'm looking at one side of a line. If I take away the 45 degrees, that's going to leave me with what's left for this side. So if I put that in my calculator, 180 minus 45, I get 135 degrees. So this angle here is 135 degrees for this green angle. Angle 1 is 135 degrees. But remember, angle 1 is going to be vertical here, which means this side is also 135 degrees. Okay, because everywhere I have a linear pair, 135 plus 45 is 180. 135 plus 45 is 180. 135 plus 45 is 180, right? You can go all the way around. 135 plus 45 is 180. Okay, let's look at the next example. All right, when I look at the next one, I've got the measure of angle 3 is 83. So 3 is 83 degrees. That means the vertical angle across from it is 83 degrees. So I knew this because of the linear pair, or the vertical angle postulate tells me those are both the same. Okay, so angle 1 is 83 degrees. Now, I need to find the measure of angle 2. So when I look at angle 2, I can see that angle 2, if I cover up part of this picture, angle 2 and angle 3 make a line. So together they make 180 degrees. So if I do 180 minus that 83 degrees from number 3, that's going to give me how big angle 2 is. So angle 2, 180 minus 83 is going to be 97 degrees. So angle 2 is 97 degrees, which means also that angle 4 is 97 degrees. Okay, so there, notice we're using both the linear pair postulate and the vertical angle postulate, and when I was given one angle, I can find all the other angles in that picture. Okay, in the next video, we're going to look at how we can add some algebra to this.